So, as we've seen at different points in this unit, sometimes quadratic equations don't have x-intercepts. They don't have solutions in the real number system. And it was actually considering these kinds of quadratics that mathematicians first started looking into the idea of imaginary numbers. But we can find imaginary solutions or complex solutions to our quadratic equations, and in fact, they will always have solutions if we consider the whole complex number system. They could be all real, they could be all imaginary, or they could be both and be complex numbers. So looking at this first example, we got 4x squared plus 10 equals 0. We don't need to use any of our more complicated methods like completing the square or a quadratic formula to solve it. We can just undo operations. 4x squared plus 10, subtract 10 from both sides, gives us 4x squared equals negative 10. Divide both sides of our equation by 4. Gives us x squared equals negative 10 over 4. Square root both sides, and we get x equals plus or minus square root of negative 10 over square root of 4 is 2. And since it's the square root of a negative, then we find that x is plus or minus root 10 over 2i. And so that is our imaginary solution to this particular quadratic equation. Here's another quadratic equation. 16 times x minus 5 squared plus 27 equals 0. And when we have, this is in vertex form, when we're in vertex form, we can solve it by just undoing operations. We don't need to use quadratic formula. This one might already have had the square completed. Subtract 27 from both sides, gives us 16 x minus 5 squared equals negative 27. Divide both sides of the equation by 16, which gives us x minus 5 squared equals negative 27 over 16. And then to cancel out the radical, we square root both sides, which gives us x minus 5 is plus or minus square root of negative 27 over square root of 16 is 4. And then we add 5 to both sides, and we get x equals 5 plus or minus, and then we can think about simplifying this. Since it's a negative under the radical, an I is going to pop out. And 27 is equal to 9 times 3, and 9 is a perfect square. Square root of 9 is 3, so that's 5 plus or minus 3 root 3 over 4i for our complex solution. So sometimes when you're doing this, you will have to simplify a radical just like you have in other cases. If you're given an equation that's already in standard form, I would say your best bet is to go ahead and use quadratic formula. X squared plus 6x plus 11. So a is 1, b is 6, c is 11. So it's negative 6 plus or minus square root of 6 squared, which is 36, minus 4 times 1 times 11, all over 2a. So we get negative 6 plus or minus square root of, it'll be 36 minus 44, which is negative 8 over 2. 8 is 4 times 2. 4 is a perfect square. The square root of 4 is 2. So root 8 is 2 root 2. And the negative inside the radical becomes an I out there. And since both of these are, both 6 and 2 are divisible by 2, we can divide both of them by 2 to simplify. So we get negative 3 plus or minus root 2i. Sometimes when you have something like this, people will put the I in front of the radical because when you're writing it, it could be unclear. Like it could look like you're putting the I under the radical, but there's never really an I under a radical because you'd have a root under a root, and that doesn't really happen very often. So I think it's fine to write it like that, and it is more proper in standard form that way. I just want to do one more example where we use quadratic formula. If you have this equation, negative 4x squared plus 3x minus 3, you're going to get negative 3 plus or minus square root of 3 squared, which is 9, minus 4, times negative 4 times negative 3, AC, all over 2a. So that's negative 3 plus or minus square root of 9 minus, there are 3 negatives, so it does stay minus. 4 times 3 is 12, times another 4 is 48. all over negative 8. So we have negative 3 plus or minus square root of negative 39 over negative 8. And we do that piece by piece. Negative 3 over negative 8. Those negatives would cancel out. It gives you 3 over 8 plus or minus root 39 over 8. And that negative under the root comes out as I. 39's only factors are 13 and 3, which aren't perfect squares. So that one doesn't simplify at all. But that is your standard form answer for your complex solution to the quadratic equation. So again, quadratics always have solutions in the complex number system. And if there are imaginary solutions, they are always complex conjugates of each other. The positive and the negative, two different answers, are complex conjugates of each other. So if you multiply them together, you do get something real. Yeah.